In this part of our logarithm video, I want to introduce to you a single logarithm number that will rather give us a decimal answer instead of a whole number. Now, let me take this opportunity to take you a little back to the previous video in part 1. I gave you an example like log 81 base 3. Now, this is a single logarithm because we have only one log. The number is 81 and the base is 3. Now, if you take your time to get a final answer for this log, either using a scientific calculator or using your own approach, you realize that the final answer for this is 4. Now, how did we get log 81 base 3 to be 4? It is simple. I taught you, since it's a logarithm, you use the base as your secret to get the final answer. How is the secret? It is like this. 3 must raise to a certain power to give you 81, or 3 must multiply itself a certain number of times to give you 81. Now let us see how it is done. 3 times 3 times 3 times 3. That is this base 3. 1, 2, 3, 4. It will multiply itself 4 to give you 81. We can also say this or write this in another form as 3 raised to the power 4 must give 81. Either ways, this base 3 must have a power of 4 or must multiply itself 4 to give 81. So 3 raised to the power 4 is 81, and that is why log 81 base 3 is 4. Now at this point, we want to ignore logarithm numbers or single logarithm numbers that gives a whole number as an answer. We want to look at other logarithm numbers that actually do not give the final answer as whole numbers. They rather give their numbers as decimal or fraction. Depending on how the log is, the final answer will be a decimal or a fraction. Let us take a look at those logs. An example of such logarithm is the log of 5 base 3. Yes, log 5 base 3. Now, take your time. Analyze it well. You realize that the 5 is the number for the logarithm and 3 is the base. But there is no way 3 can raise to a constant power to produce 5. Or there is no way 3 can multiply itself a number of times to produce 5. That is trying to tell you that this single logarithm's answer must be a decimal. Now when you take your calculator or you find your own way to do this, you realize that the answer for this is a decimal this way. 1.464973521. It is very long, right? Don't worry. I just put it down to just exhibit the answer to you. You can approximate this, but that is not important for now. Let us see. Take a scientific calculator, put log 5 base 3 and put it on the calculator. Just get an answer with your equal sign. You realize that this is what will appear on your screen. That is trying to tell you that it's the same structure. This base 3 actually must raise to the power 1.464973521, and then the final answer for 3 raised to this decimal power must be 5.00000, which actually means 5. It is very true for the parts that we talked about, that the base actually contributes to this number of the logarithm. So this log here is now going to be used in our complicated logarithm, where the addition, the subtraction, the division, and the multiplication signs comes in. So with that, we are going to introduce ourselves to a new phase of logarithm where the laws of logarithm must be taught to be used on these numbers, and then the properties of the logarithm must be taught to be used on these numbers. So in the next form of our video, we will look at the law in its proper way. Let's take a look at the laws of logarithm. I'll now introduce you to the laws of logarithm. If you remember, I introduced a single log with the final answer gives you decimal. That is the reason why the laws of logarithms are there to guide you to handle those values of log that will result into decimals. It will show you how to handle them well. Let us zoom into the laws of logarithm. Now, law number 1, that is the first law of logarithm. Let me give you a log question. Log 5 base 2 plus log 3 base 2. Now, please, the law of logarithm number 1, or the first law of logarithm, let me give you a nickname. That is another name for it. You can call it the addition law of logarithm. Let me tell you the reason. The secret is, if you don't see an addition sign separating 2 single logs or 3, or separating single logs, you can never use the first law of logarithm. I repeat, the addition sign is the only gateway to use the first law of logarithm on logarithm single questions. Let's continue. If we have an addition sign, this is what the law tells us. The law states that check whether the bases are the same. If the bases are the same, please, this is an easy way to do it with my own method. Once the bases are the same, there's something also same about them. Log base 2 actually becomes the target. I will put one of the log and with a base 2 close to a single logarithm. Now that I have my single logarithm in place from log base 2, I have log base 2, which actually is like a single logarithm for the two of them. Now, I will go ahead and apply the real law. Now, the law says that because I see addition, the numbers for the two logs, you multiply them. I repeat, the numbers for the two log, please multiply them. This is what I mean. Bring a bracket to house it well for you. Now, this bracket in place shows that I want to put a certain number in it. Now, the numbers 5 and 3, multiply them because of the addition. I repeat, multiply them because of the addition. So it will be the number 5 times the number 3. So the law says that anytime an addition sign separates two log with the same basis, please multiply the numbers. 5 times 3 will give us 15. So this will become log in place. 5 times 3 is 15. Now the base is 2. So we have converted log 5 base 2 plus log 3 base 2 into log 15 base 2. Simple, using the first law. Please, I am begging you. Somebody will ask that, sir, why have you left your answer this way? I am begging you once again. Leave your answer in the log form or the single log form. If your logarithm question or the logarithm final answer cannot be a whole number, once the question gives you a final answer that you cannot convert into a whole number, leave your logarithm this way to signify a single log, because the decimal may not be the right way of converting it. So leave it this way. It is simple. I can't get the whole number from this log, so my final answer will be log 15 base 2. Let us take a look at the second law of logarithm. Let's now take a look at the second law of logarithm. So law number 2. Now let me give you an illustration like log 2 base 7 minus log 3 base 7. Now if you check, these are two single logarithm questions that cannot give me whole numbers. Even if they can give me whole numbers, I am still supposed to apply the law. The secret is, the second law also is referred to as the subtraction law. It is a name that I have given it for you to understand that without a subtraction sign, you cannot apply the second law to the log values. Now, how do we apply it? I must make sure that the log to the base, log base are the same. So I have base 7, base 7. If the bases are not the same, I'll show you another thing to do. But for now, let's concentrate on the same basis. Base 7, base 7. What did we do? Since the log base 7 are virtually like the same, let us put log base 7 as our single log. Showing this log base 7. We put it there as our single log. Now the next thing is the law. The law states that because it is a subtraction, please divide the numbers of the logs. The log number here is 2 and the log number is 3. Since there is a subtraction, I will divide the numbers. So let me bring my bracket to house the final answer nicely. So it will be the number 2 divided by the number 3. So this is what I mean. Because of the subtraction, I use the division for the numbers. Now this can also be written nicely as the log of 2 divided by 3, which is 2 divided by 3 to the base of 7. As I rightly said, most of the times students prefer to use a bracket to just put the fraction as a single unit. So the fraction is 2 over 3 base 7. So this final answer becomes log 2 over 3 base 7. And actually it's a fraction. Now, someone can choose to convert this into a decimal. But as I said, since this cannot give me a whole number, why don't you prefer to leave your answer in a single logarithm? So the value for log 2 base 7 minus log 3 base 7 with the help of the second law will give us log 2 divided by 3 base 7. Let us take a look at the third law of logarithm. Let us now take a look at the law number 3. So third law, law number 3. With the third law, please, I want you to take your time. It could be used in two different ways. At a certain point in the logarithm, I'm going to teach you how to reverse all the laws of logarithm. But for this third law, I'll teach you right now because it will be very vital in our procedure. Law 3. Let's say I have a value called 2. Then I have log, let's say 3 base 5. When you have this single log, if you can cast your mind back from the beginning of the log, I wrote the log without any number before the L. That is to say, no coefficient for the log. The log was without any number. But in this case, there is a number here. Now, this is where the law comes in. The third law comes in to help you when these numbers are there. Any number here can be moved to become a power of the original number of the log. This is what I mean. You can move these 2 up here to become a power of this 3, which is the number of the log. So that you can now write this in this way. Log without the 2 here. But now the 2 will come here. 3 raised to the power 2. The 2 has now moved here to become the power. Now base 5. And this will now convert into a final part as 3 power 2 is 9. So I get log 9 base 5. And this is the character of this law. And this law can be done in another way. Let us see what we mean. If we have, let's say, something called log, let's say 4 raised to the power 3, let's say to the base 7. And you don't want to make use of this 3 as 4 power 3. You can now use the law to bring the power back here to become a coefficient of the log. That is what I mean. You can move it to this side of the value or the log. So let's go. This is what I mean. Now 3 will move down here with the help of the third law. It is something the third law can do. So the 3 comes here before the log. So 3 has now come here. And then the 4 is now free without the power to the base 7. So ladies and gentlemen, these 2 ways of exhibiting property 3, you can do it based on what you actually need or the procedure you are using in a particular question with logarithm. I will take my time to explain these ones very well. But before that, let us take a look at the properties or the characteristics of logarithm. Then we solve 1 or 2 questions to convince you that log is actually easy. At this part, let us take a look at properties of logarithm. Here, we want to take a look at what logarithm actually exhibits in terms of character. How do we write logarithm and convert it to another thing in mathematics? So these are just the characteristics or the behavior of logarithm values. Let us start from property number 1. So I'm trying to say that property means the character of something. So property number 1. Anybody who writes logarithm with a number and does not bring a base has written the same logarithm to the base of 10. Meaning that logarithms without a base is in base 10. So this can also be written as log 3 to the base of 10. This and this are the same. That is property number 1. Property number 2. Property 2. Now, any logarithm whose number and the base are the same becomes a value of 1. This is what I mean. The log of a number 5, base 5. Since the number is 5 and the base is 5, in logarithm or with a log there, the final answer of this entire log is equal to 1. That is the meaning. So let me give you another example. If I have the log of, let's say, 3 to the base of 3, we get a value of 1. Even if I use a variable that is unknown numbers and I say the log of x to the base x, once the log's number and the base of the log are the same, our final answer must become 1. Please take note that these do not apply to negative values and 0. Any negative value for the base or for the number or 0 for the base or for the number is not applicable. It becomes a math error in terms of calculation. So please take note of that. But finally, the log's number and the base appearing in the presence of the log, the final answer for that particular log number or single logarithm is 1. I will now take a look at a final property called property 3. Even though we have so many properties along the line, but these 3 properties are very essential in solving log question. Property number 3. Anytime you have a log to 1 as your number to any base, let's say base 5, since the number of the log is 1, to any base which is positive and not 0, that is numbers which are greater than 0, then the final answer for this log because of the 1 is equal to 0. I repeat again, the base must not be a negative base or 0. Once it is not a negative base or 0, and then the number is 1, because of this 1 to any positive base, then the final answer for this entire log is 0. Let me give you another example. If I have the log of 1 base even 100, you get the final answer at 0. It is simple. If I have log 1 to the base of 2 and I'm getting 0, it is just trying to tell you that 2 raised to the power 0 is actually 1. Or what power of the 2 will produce 1? And the power is 0 because 2 raised to the power 0 is 1. So this actually confirms that indeed log 1 to any positive base is 0. So take note of these 3 logarithms. Now in the next video, I am now going to solve complicated questions of logarithm with you using the laws and the properties of logarithm. Let us go to the next one. Now at this point, we take a typical example for logarithm. It says simplify 3 log 2 base 10 plus log 20 base 10 minus log 1.6 base 10 as a single logarithm. So this is so clear. These are about 3 logarithms and we want to reduce them into a single logarithm. Let us start. Let's write the log. It becomes 3 log 2 base 10 plus log 20 base 10 minus log 1.6 base 10. Good. First of all, please, we are begging you, take note of this. Anytime you want to apply the laws, I have seen an addition sign, so I can apply the first law. I see a subtraction sign, I can apply the second law. But just go by the one that comes first. Addition came first, so we apply the first law. But before you apply the first law, there should be no number in front of the log. When you check the first log, I have 3. It means that the 3 must move with the help of the third log to be a power of the 2. Here there is no number, so this log is free. And this one there is no number, so the log is free. So the number in front of the log or the number before the log is 3. I'll move it here. So this is how I'll write it. Log 2. 3 moves to become power 3 base 10. Then plus the rest can be written because they are just log which has no coefficient, no number here. So it becomes log 20 base 10 minus log 1.6 base 10. Now your log is free. So please take note. No one must apply the first or the second law of logarithm if the log has a number before the L that is a coefficient of the log. Move it with the help of the third law so that your log will be free without any number or coefficient. Now let's simplify. 2 raised to the power 3 is 8. So it becomes log 8 base 10 plus log 20 base 10 minus log 1.6 base 10. Let's first of all apply the addition law or the first law of logarithm, then followed by the subtraction law or the second law of logarithm. From this part, we want to apply the first law since there is an addition sign here. So log base 10, log base 10, they are the same. Just always check for the base. The bases are the same. Log to the base 10, log to the base 10. So I repeat, log to the base 10. Then what do I do to the numbers? The number 8, number 20, because of the addition sign, the first law says multiply the 2 numbers. Let me bring my bracket to multiply it nicely. So 8 multiplying 20. Then I will repeat minus this log. So minus log 1.6 base 10. Most of you also prefer to just divide because there's a subtraction sign. But what I'm doing is I'm going gradually, step by step. I first of all use the first law because of the addition sign, and I multiply the numbers, the number 8 and number 20. Now I'll simplify this into a single log, then I'll come back and use the second log. Now let's simplify. We can simplify this into log 8 times 20 is 160 base 10. Then we bring this, repeat it, minus log 1.6 base 10. You can go ahead and do it straight, applying the first law and the second law instantly in one step. But what I'm doing is I want them to appreciate how the law actually affects logarithm so that it will be a systematic step for you to understand very well. Now that I have the subtraction sign in place, with the log having the same basis, I can apply the second law since it is a subtraction law or the subtraction sign is there. So the base is 10. The base is 10. I'll write the log with a base in place. Now what I do is I will divide the number 160 and the number 1.6 because of the subtraction sign. So let me bring this my bracket. 160 divided by 1.6 and then still in the base. Now 160 divided by 1.6 is 100. Let us write it well. 160 divided by 1.6 is 100. If you use your calculator, just do this on calculator. Only 160 divided by 1.6. Do that one alone. You will get 100. So let us now write it well. So we bring our log. The value here in the bracket for 160 divided by 1.6 is 100. Then the base is 10. Now at this point, you will now ask yourself the final question. I have a final log. Ask yourself this question. From the beginning, we learned that not all logs can be converted into a whole number. Now, can log 100 base 10 be converted into a whole number? That question can be answered this way. Can 10 as a base be raised to any power to give you 100? Or can 10 as a base multiply itself a certain number of times to give you 100? And the answer is yes. 10 can multiply itself 2 times. That is 10 times 10 to give you 100. Or 10 can raise to a power of 2 to give you 100. So that means that finally log 100 base 10 is equal to 2. So our final answer for the entire question is 2. That is how we understand it. Please pause the video, go through the steps one after the other, understand every strategy or every movement I made, and then leave a comment in the comment section. Comment on this video. If you want more videos, please let me know. I'll give you more videos on this. Let us go to the next part where I solve another logarithm question to arrive at an answer which is not going to give you a constant number. We want to take a look at the second question under logarithm. In this question it reads, simplify 2 log 3 plus log 9 minus 3 log 3 as a single logarithm. If you analyze this question very well, it is a logarithm question because we have the log, the log throughout. Now this logarithm do not have an equal sign, so those of you asking comments on the equal sign, we'll get to that side. Now let us solve this question. There are 3 different logarithm numbers here, and we have been asked to simplify or reduce them into a single log or 1 log. So we have to do that with the properties and then the laws of logarithm. This log has no base, meaning the base is base 10. Let us rewrite it well. So we have 2 log 3. You can put your base 10 or leave it without a base. No base means base 10. So let's continue. Plus log 9 minus 3 log 3. Now I taught you about the laws. There is an addition sign, so thank God we can use the first law. There is a subtraction sign, still the same thing, we'll be able to understand. So we can use a second law. But before you use the laws of logarithm, please make sure the log has no number before it. That is to say, before the log, there is no number or there is no coefficient. Here there is a coefficient of 2. And even here there is a coefficient of 3. So I'll have to use the third law of logarithm. The 2 will move to become a power of the number 3. So let us write it well. So this is how you become the log. No 2 here, but it will move. 3 here becoming power 2. So the 2 has moved to become a power of the 3. That is why it is here. Now plus is the next sign. There is no number here, so we can repeat this log. So it's called log 9. Then the next log has 3 before the log. So move the 3 to become a power of the number 3. So this is how we write it. Minus log. The 3 will move to become 3 power 3. Somebody will ask, what about the minus? Leave the minus in place, but move the number to become a power. Now simplify. 3 raised to the power 2 is 9, so it becomes log 9. Now plus another log 9. Then minus 3 raised to the power 3 is 27, so log 27. Now remember, all the bases are base 10. So let's continue from there. With operational signs, the addition comes first and the subtraction is second. So it means that the first law of logarithm, called the addition law, will be applied first of all. The log is to base 10 and this log is to base 10. So it means virtually the bases are the same. So let's write the log. I'll write the log. Someone can prefer to bring base 10, but I'm leaving it because it's still base 10. Log without base is in base 10. So let's go. The numbers will then have to multiply because of the addition. The law states that anytime you see addition between 2 logs, multiply the numbers. The first number is 9, so I use bracket to do it well. 9 multiplying the next number is 9. Then I'll bring the minus. Then I'll repeat the last log, that is log 27. So many students will prefer to do it instantly by dividing. But as I said, I want to go gradually and step by step. So I apply the first law because I saw the first sign as addition. Then when I'm done simplifying it, I'll now move to apply the second law because I've seen a subtraction. So let's simplify this side of the log. 9 times 9 is 81. So I get log 81. The base will not come because it's still base 10. Then I'll repeat the next log, which is minus log 27. Now that I have the subtraction sign in place in between the 2 logs, I will now use the second law, which is the subtraction law. And the second law states that since there's a subtraction sign, check whether the log and the base are the same. So log base 10, log base 10. Since there's no base, it's in base 10. Then I'll repeat log without the base. Without the base, since it's in base 10. Now let's continue. We will now divide these 2 numbers. So let me bring the bracket to make the division a single entity. So 81 as the first number, because of the subtraction, division. So you divide the next number, which is 27. So you divide it by 27. Still with a single log. Now let's simplify this and get the answer for it. At this point, so many people will have to compare this into a normal division. That is to say, log of 81 divided by 27. Please, when you do it this way, you still get the same answer. Okay, this and that are the same. Division here The bar here means division. Now 81 divided by 27 is 3. So I'm going to get log 3 to the base of 10. Now watch here. Let me intentionally bring the base at this point so that you see clearly. Even though I didn't bring it from the beginning, when I bring it here is the same thing. Now look at this. Log 3 base 10 cannot give you a whole number. Why? Because there is no way the base 10 can raise to a power to give you 3. 10 cannot multiply itself in no number of times to give you 3. Or 10 cannot raise to any power to give you 3. That means that log 3 base 10 will give you a decimal value. That is what it means. So whoever gets a decimal value, if you want to write the answer, that will not be a problem. But please, since it is not going to convert into a whole number, leave it as a single log. Because from the beginning, if you realize, from the beginning, the question asks for a single log, and the single log is here, log 3 base 10. So this is the final answer for the entire question that we're given. Thank you very much. Please continue to watch our videos. Leave a comment in the comment section if you want us to do more videos and the topic you want. Please leave a comment, and please share this video to all those who find this video very important to them. And also like this video. Please follow us on TikTok and also subscribe to our YouTube channel. Go to YouTube and look for Math Made Easy -MME. That is the channel's name, Math Made Easy with a -MME or the -MME. Then subscribe to our channel. We have more videos uploaded there. Please hit on the bell icon to be able to be notified anytime we upload new videos. My name has been Anthony Osei Mensah, popularly referred to as Tony the Mathematics Doctor. I will come your way next time with more videos. Please, thank you for watching the video. Help us by sharing. Thank you. God bless you and see you later.